In Chapter 5, we have talked about the three forms of a linear equation: slope-intercept form, point-slope form, and standard form. You can think of them as three distinct forms of the same thing. I prefer to think of them kind of on a continuum. Once you have one, you can always use that to get to another. If I have an equation in standard form, I can always use that to get to slope-intercept. I can always use slope-intercept to get to point-slope, and vice versa. So I think of it more like a circle than I do as three distinct forms. There are three variations of the same thing. This video is going to focus on how we can use those linear equations, those three forms, to interpret word problems. The packet you've been given has 20 problems on it. They're divided into separate sections, and those separate sections give you an indication of what to look for. At the end, you're going to see some problems that say, now you figure it out. Ultimately, we want you to be able to look at a problem and figure out what information you have, what you can do with it once you figure out what you have. But let's start at the beginning. We're going to talk through one of each type of examples. So let's start with number one. Number one, it clearly tells you, is going to be a slope-intercept form of a line. That's because in these problems, you should be looking for the fact that you're given a rate of change and a starting point. Specifically, because it's slope-intercept, that starting point is going to be the point 0 something. So let's get started. The first problem. You and your friends plan to attend the country fair this weekend. The admission to the fair is $5, and the cost per ride is 50 cents. If your parents give you $20, write and solve, this is an indication that I should be doing two things here, a linear equation to find how many rides you can go on. So I'm not worried for the time being about the solving part. I want to focus on the writing part. So, have they given me a rate of change? Well, is $5 a rate of change? Am I going to be paying that on a regular basis, again and again and again? I would argue no. $5 is what you pay when you walk in the door. The cost per ride is 50 cents. Well, am I going to be paying that again and again? Yes, I'm going to be paying that for every ride. So, in my mind, they have this written in cents. I'm going to write it in dollars because this is written in dollars. So I'm going to write it as 0.50. That's my slope, or my rate of change. And then my starting point is how much I paid that one time when I walked in. So that's going to be $5. What you should understand is that they have given you the slope as 0.5 or 50 cents, and they've given you the y-intercept as 0.5. If you go on 0 rides, you will pay a total of $5 just to get in. Therefore, x becomes your number of rides, and I should bring that arrow over here, and then your y becomes your total cost. I'm not saying that for every problem you have to outline that, but it might be something that you want to think about. In the past, we have discussed the fact that x should be your independent variable, and y should depend on x. So my total cost should depend on the number of rides. Ultimately, what I'm trying to get is a linear equation. For this problem, it makes the most sense to write that linear equation in slope-intercept form, because I've been given a slope and an intercept. If you were to give me, for this problem, a linear equation in a different form, I would absolutely accept it. However, it makes the most sense to use the slope-intercept. So I've got y equals mx plus b. This problem gives me my m as 0.5, and it gives me my b as $5. So the first part of this problem was write an equation. Once you understood the information that they gave you, that's relatively easy. Now we're going to go back. Initially I said I didn't want to worry about solving the equation, but now I do. I've answered part A. Now I'm going to use what I have from part A to actually solve for this specific situation where they've given me $20. I have my equation, y equals 0.5x plus 5. I have to figure out where to plug $20 in. That's where understanding what your x and your y are is very helpful. $20 is how much your parents gave you, so that's going to be your total cost. I'm going to plug it in for y. I want to solve for x, the number of rides I should go on. I'm going to use my inverse operations. If I pay $5 admission, that means I have $15 left to spend on rides. If it's 50 cents per ride, then I should be able to go on 30 rides. I know that I used an equation here to solve for x. However, this is a word problem, so I'm not going to put my answer in solution set. My answer is how many rides I went on, so I'm going to say it was 30 rides. Make sure my answer is pretty clear there. For the rest of the problems in this section, you should be approaching them in a similar way. Look for a rate of change. Look for a starting point. If you're given those things, the easiest path to go to get a linear equation is slope-intercept. Before I move on to the next problem, I just want to make one note clear. I plugged in for the specifics for this problem, but you should know that the rate of change is the same thing as the slope, and the starting point is the y-intercept. I believe that's what we probably should have written there. I got a little bit ahead of myself using it for this specific problem. We're going to skip down to number 5 and look at standard form. We use standard form when the problem relates two different objects. Just a reminder, standard form is ax plus by equals c. For this problem, Sam ordered 2 tacos and 3 enchiladas for lunch at the restaurant. His bill came to $7.80. If enchiladas were $2 each, write and solve a linear equation to find the cost of each taco. So, again, I'm going to ignore the solve part for the time being, and I'm just going to focus on writing a linear equation. Technically, I could give my answer in standard form, slope-intercept form, or point-slope form. But because I have two different objects in this problem, it makes the most sense to use standard form. I'm going to start by saying that my first object we'll say is my tacos. So I have 2 tacos at X dollars each. I'm going to add to that the cost of enchiladas. I have 3 enchiladas and they're going to cost Y dollars each. The total bill was $7.80. That's my linear equation. Hopefully you can see, because I had 2 different objects, it's much easier to use standard form than trying to worry about what a constant rate would be, which would be a slope. You would need a slope for point slope form or slope intercept. So part 1, writing the equation, is done. Let's go back and let's talk about solving it. So to solve this equation, I'm going to take it, 2x plus 3y is equal to 780. Just a quick note, it would be totally fine if you used, instead of x and y, for this problem, maybe you might want to use 2t and 3e because we're talking about tacos and enchiladas. That might be helpful when going to plug in to solve the equation. I've also been given this information over here that I have $2 as the cost of an enchilada. So let me write my equation down here. I'm going to keep using that t, but I'm going to plug in 2 for the cost of an enchilada. Now I'm going to go ahead and solve. The cost of a taco is going to be, and this is a 9, sorry about that, 90 cents. Let's go back and make sure I've answered the question. It says, write, I did, and solve a linear equation to find the cost of each taco. So the cost of each taco is 90 cents. Let me write it over here. So 90 cents per taco. And when I have a lot of numbers floating around in a problem, I do tend to circle, or in my case right now I'm using a box, to go around my final answer.